Hey everyone, my name is Quinn Kuslich and I'm a professional VR developer, and today I'm going to be teaching you how to get realistic hand physics in Unreal Engine 5. What this means is that when you launch a VR scene and you have hands in front of you, you'll be able to push it up against both real world and dynamic objects, and the hands will react realistically to the objects within that scene. This is a pretty complex system to set up, but I've developed this tutorial in a way that pretty much anyone can do it. However, there are a few things I'd like to address before we get started. The first one is a VR procedural grip tutorial that I created a couple months ago. This goes into the VR pawn, the grab component, and the hand animation blueprint, and changes things around and adds some systems that we're going to be building on top of inside of this tutorial. So you can follow along with a generic VR project if that's what you need to do and you don't want to follow the procedural grip tutorial. However, it is building on top of systems that already exist, so your screen might not match mine at sometimes. Good news is that this tutorial is free on YouTube, so you can follow that one first and then come back to this one. Or if you don't have the time and you're just trying to get physics working in your project, you can actually go to my YouTube page. I have a link up here at the top where it'll bring you to my Gumroad. And this is where I sell code from all of my tutorials. So the code for this tutorial will also be on this Gumroad page. And I'm actually going to combine it with the procedural grip system, and it's going to be $15. But if you want to pay $5 and just get the project, you can actually download my entire procedural grip animation template right away and then just get started with this video. It's up to you. It's got a lot of great ratings. Everyone who's bought it has loved it. And I actually really appreciate people who buy it and give ratings. It's awesome. I try to keep everything, reasonably priced because I know that some people are, professionals in the industry and other people are just getting started and they don't have a ton of money to throw into VR development. So I try to keep everything fair when it comes to pricing. With all that said, let's jump into the tutorial. I'm really excited to share this with you guys. You've been asking me for it for a while, and I think it's going to be awesome. First thing we want to do is make sure our headset is plugged into our computer and set up through Questlink. If you don't know how to do that and need to learn, I have a tutorial on it, which I've linked below. But I think just to make everything easier, we're going to start by just pulling a project directly from my Gumroad page so we can start fresh with a new project and you guys can follow along with me. So I'm just going to go and I'm going to buy this product. Now that this is downloaded, I'm going to go into my downloads folder. I'm going to extract it into my folder where I keep all my projects. Once that is completed, I have my Unreal project file right here. I'm going to take this and I'm going to drag it over my Unreal 5.5 logo on my desktop. Now I'm using Unreal 5.5.1. That's the most recent version of Unreal, and I think it's best for this tutorial. And it has, settings that we need to change, and you can do this in 5.4, 5.3, or probably even 5.2, but I'm going to do it in 5.5. So it's up to you. Do whatever you want. It should not change how the code functions. Okay, so now that we have our project file open, we're going to go to the upper left here. We're going to go click on VR Preview after we click this little hamburger menu. And if that's not an option for you, it's because your headset isn't connected properly, so make sure you do that. So let's go ahead and jump into this file, and we'll go over what I have so far. So still teleport on the right hand. If you follow the thumbstick tutorial, that will be different for you. But if you reach out and grab these objects, you're going to see that we have procedural grip on every object in the scene. I'll pick up objects actually. So, that's the functionality that I covered in the last tutorial on this topic. Well, on the hands aspect of this topic. And so that's kind of what we're starting from as a baseline for this physics tutorial. Jumping straight into it, there's a few things we need to cover so you know how this works. Essentially, we're going to create two different hand models. One of them is the hand model that will always follow our controller. That's the tracking hand. And then we're going to have our physics hand, which is like the hand that actually the player uses to interact with the world. It's got all of the logic for picking up objects and like shooting guns and doing a bunch of different things. And then we have a tracking hand that its job is just to follow the controller and provide a frame of reference for, what the physics hand is supposed to do, like where it's supposed to be, how it's supposed to manipulate, and what it's supposed to be rotated as. So, and that's how they set it up in Half-Life Alyx. You have a tracking hand and then you have a physics hand. And they actually have another hand that handles like welding, which we're not doing. We're actually going to be creating a custom physics asset for this hand, which is exactly where we're going to start. So what I want you to do is go into the content browser. Now, if yours does not look like mine, if this is like your first time launching Unreal, you just go to Window, load layout, and then you want to load that UE4 classic layout, and that'll give you the same setup that I have here. And then you're going to go into the characters, mannequins XR, meshes, and you're looking for the... Actually, we can start with either one of these, but we're going to start with the right hand first. So we're going to find this skeletal mesh asset, and we're going to right-click on it. We're going to go Create Physics Asset, and then you go Create and Assign. So what this is going to do is build us a physics asset that we're going to use to control how the hand reacts to objects within our scene. It controls the physics of that skeletal mesh asset, which is the hand. So we're just going to go and create. And what that does is it just creates one ginormous capsule around our hand, which for now is fine, but I want to adjust it because eventually we're going to create different colliders for each finger and each joint in the finger so that it realistically collides with things. And that will happen at the end of the tutorial after we've gotten all of our functionality down. So what I'm going to do is drag this back here. I'm going to scale it way down so it's like kind of like a long skinny cylinder that would take up like, you know, kind of the hand where the palm is. And I will explain how to do all of this in greater detail before, but like just basically follow my instructions. If you want to move it, you're going to press, can't remember, like, all right, so R is scale, W is move, and then E is rotate. So I don't go up here and click these things, I just use the hotkeys. So W, I'm gonna move this into position and kind of like line it up correctly, and then I'm gonna press E, I'm gonna rotate it so it kind of matches this, and I want you to do your best to match what I have here. And then we're going to, yep, no, that looks, I think that's fine for now. We're going to have to do the same thing on the left hand, by the way, but we're also going to go into the settings on the right hand side here, and we're going to look at this physics type. We're going to change that to simulated, and then we're going to scroll down to the advanced settings, and we're going to go all the way down here where it says sleep family. You're going to change this from normal to sensitive. Then you're going to just save this. We're going to use this asset inside of our VR pawn when we're setting up all of the stuff that we need to set up. So now we're going to close this asset, and we're going to do the same exact thing for the left. So click on the left, right click, go to Create, Physics Asset, Create and Assign. Same settings as before. So now we have the hand L. You can see the collider over here in the left-hand side, and we're going to do the same thing. So I'm just going to speed that up because I already showed you how to do it in the first place. And then make sure you set the physics type to simulated and the sleep family to sensitive. And then you're going to compile and save both of those things. Now that we've created the skeletal mesh asset, and some of you guys might be wondering, why am I not just using the same physics actor for both hands? Because our hands are different. This is the right hand, this is the left hand. It's mirrored. We can't actually just mirror a physics asset over, at least not that I know of. If anyone has a way to do that, that would save a lot of time on this tutorial, so if you figure that out, please let me know. Anyway, we're going to go into the left hand first. So we open up the skeletal mesh asset. It's this little pink one right here, and it says skeletal mesh at the bottom. You can dock that at the top. We're going to type physics. So as you can see, we've already created and assigned it, but what we're actually looking for is this little checkbox right here, which is enable per body collision. This is going to allow us to actually use the individual colliders that we're going to put on these fingers at the end of the tutorial, so that like when you make an index finger and you interact with an object, it doesn't just take the entire collider itself and doesn't manipulate it. It's a per body collision. And you know, we want it to be as realistic as possible. Because when I touch this, you know, microphone, for example, it's not my hand palm doing it when my finger is the thing touching it. So go ahead and set per body collision for the left, and then we're going to close this asset, and we're going to go open our right skeletal mesh asset. And I'm just going to dock it at the top. Same thing, we're going to type in physics and click enable per body collision. So cool, we have that done. Those are our physics assets. They're very low level, they're pretty simple, and honestly, if you were to just keep those as they are and finish this tutorial out, you will have physics hands, but we're going to take it a step further because this is an advanced tutorial. So now we have to actually tell our pawn to use these physics assets with constraints. But we also want to set up some way to distinguish between our tracking hand and our physics hand. So we're going to create a holographic ghost material, similar to the design of the material in Half-Life Alyx when you like close the menu, because when you close the menu, your physics hands disappear, and then the tracking hands are the, you know, dominant hands that you use to interact with menus and stuff, which is cool and easy. So if you want to make it do that, we can do that too. All right, and this is a really simple material. So don't worry if you've never made a material before. I'm going to explain everything. It'll be easy to understand, I promise. So we're going to go down to our VR template. We're going to open up the materials folder because this is where I want to put it. I want to put it into the materials folder. I'm going to right click in here. I'm going to press create material. I'm going to call this m_qk_ghost hand. All right. And then I'm going to immediately grab this and create a material instance and call this mi_qk ghost hand. And you'll be able to set the colors of this to be whatever you want it to be. Mine's going to be yellow. And that's why we create the material instance, because it makes it easier to do that. So we're going to go ahead and open up this material. I want you to dock it at the top here. And the first thing we need to do is set up our material parameters, like, you know, what kind of material it is. And this is going to be a translucent material, and it's going to be unlit because we don't want it to be affected by lighting. It is a hologram, right? So next thing we're going to do is right up here in the graph, we're going to hold V and click, and we're going to create a vector parameter. And this will be hand color. And I want you to set that to like an orangish yellow, like this, you know, match the Half-Life Alyx colors to the best of your ability, because that's what we're replicating here. Then we're going to, underneath it, hold S and click the graph. That creates a scalar parameter, and this one will be called immersive intensity. Sorry, I'm dyslexic. And we're going to set that from 0 to 5. I want like a good glow in it, but I don't want it to be too harsh. Then we're going to go over here next to these two things, and we're going to hold M and click in the graph, and that creates a multiply node. So we multiply the color of our hand by an emissive intensity to give it a good glow. And then we need to go over to, beneath that, and we're going to create a Fresnel node. So it reads like Fresnel, but it's called a Fresnel because France or whatever. And then you're going to create two new scalar parameters. The first one is going to be the exponent in, so I just call it x pin. And I think a good value for this is going to be like 3. And you drag that into the exponent in pin of the Fresnel node. And then you're going to create another one, and this will be base. This node changed from Unreal 5.4 when I originally wrote this. It's the base, like reflection or refraction or whatever. So you're just gonna set it. You're gonna do base. Why is it called that? Oh, whatever. It's the base fraction in. And for this, I've played around with these values, and you can too, but I found that 0.04 is the best value for that. And now we take this Fresnel node, we grab the output of the multiply above. We're gonna go and drag down, and we're gonna type multiply again. We're gonna multiply these two values together to get what we need. So we multiply the color and emissive intensity by the Fresnel, and we're going to plug that directly into our emissive color and opacity. And so now you can see that we've got this like cool holographic material, which, you know, looks, it's like got like a gradient on it. It's like a decent looking material. Any mesh that we put it on, it's going to like create like some kind of like cool ghostly outline. And if you really wanted to, and you had like custom hand models, you could actually plug in a normal map here. I'm not going to do that, but it's something that you can do if you want. So we're going to go ahead and imply and save this material, and then we're going to keep note of our material instance because we're going to need it. And that is our ghost material created. Okay, now it's time to go into the VR pawn and actually set up our physics assets on the hands and create our tracking and physics hands respectively. So I want you to go to the VR template, go to blueprints, and we're going to find our VR pawn and open it. Now, I think if you wanted to not corrupt your original file, you could create a new VR pawn and just duplicate it. And then over here in world settings, you'd want to set that pawn to be the new pawn that you launch right here. But I don't care, so I'm just going to use the existing VR pawn because I know I'm not going to destroy it. But if you're using my If you're using my VR template that I'm selling, or you did my tutorial, you'll see that we have code from our last tutorial in here that controls, how the physics work. And then also inside of the actual viewport, and you go and look at these hands, right? You're gonna see that we've got our like thumbs, finger, pinky splines, like the hands that actually control, like the splines that control how our hands manipulate around an object. Those are there. And those are going to be our actually physics hands. So inside of the components tab on the left-hand side here, once you've confirmed that stuff matches, we need to duplicate our hands respectively. So we're going to take our hand left, we're going to right click on it, we're going to just press duplicate, and we're going to call this hand left tracking. So that's going to be our tracking hand. And then over here on the right hand side, I want you to go to the material and in element 0, type in our ghost hand material. Ghost hand. And then you can actually see that we have that ghost hand material now. So if I were to like drag it out and look at it, you can actually see, like, look at that. We got a cool like holographic hand. That'll be our tracking hand. And then we'll be able to like turn these hidden when we're not wanting to see them anymore. But for, debug purposes, we're going to leave them on. And once that's done, I want you to compile. And then you're going to grab the left hand, the physics hand, which is just hand left. And you're going to drag that up to this motion controller left grip because we need to unparent it from this motion controller. So we do that like so. And now it's going to appear down here just in the VR origin section. And then we're going to do the same thing for the right hand. So we're going to go grab our right hand. We're going to right click on that and we're going to press duplicate. And this will be hand right tracking. And then we do the same thing. We grab our hand right, the original one, and we go and we unparent it from the motion controller. So now these are just like floating around in space. If we were to go test everything out, they'd probably fall to the ground. I don't know what they do. We should see. So let's go test that out quick now that we've created our tracking hands, and we should be able to see what the effect is. As you can see, our physics hands, I forgot to set the ghost material for the right hand. Our physics hands are now on the ground. They're still like copying all the animations. We have to set the animations up for these holographic hands, which we'll do later in the tutorial. But for now, you can see that these are our tracking hands. Let's go back into the pawn and actually make sure that we, on the hand right tracking, we set up the proper materials so we can tell the difference between the two. Okay, so grab that, set it up, file, save, go back into the project. Okay, so now we have our physics hands are on the ground right now because we have not coded them to follow the hands yet, and we have our tracking hands here. So these are going to be the hands that always follow the motion controller, and then the physics hands will use physics to follow the motion controller using parameters that we set up for it. In order to set up the proper physics on both of our hand models and also add the constraints, we're going to first start with our tracking hands. So what I want you to do is go into the components tab here. I want you to grab your left hand tracking, and then I want you to hold control and click on the right hand tracking. That way we can set the values for both at the same time. So you're gonna go to the right here and you're gonna see that there are two materials. There are two other things. We've set the animation class of the hand already. We have multiple values for the skeletal mesh asset because we have both the right and left. We're not paying attention to the mirror functions because that is unimportant to us. And we're going to go down to the collision settings because that's what's kind of important for us at this current moment. So what I want you to do is scroll down there, and there's a few things we have to set inside of here. So the first thing we're going to do is set our collision presets to custom, and then set that to query only, no collision. So no physics collision, query only. We change it to a world dynamic object. We'll compile that. Now we need to set up the physics for our actual physics hands. So what we're going to do is we're going to go to the hand left and hand right respectively. We're going to scroll to the top here. So we're going to select both our right and our left hand. We're going to scroll to the top, and where it says physics, we want to simulate physics. And then we want to scroll down to actually set up our physics settings. So the first thing I want you to do in the collision settings is click simulation generates hit events and generate overlap events. That way we can, manipulate things and cause things to react. Then we're going to set our collision presets from no collision to custom. And then we're going to go to collision enabled, and we're going to set it to collision enabled, both query and physics. And then we're going to set our actual object type from world static to a physics body. And what this will do is give us some settings here. We want it to block everything except for the pawn, because if we don't block the pawn and we're like doing thumbstick locomotion or something like that, the capsule will actually interact with our physics hands and cause the entire system to freak out. And then finally, we want to go down to the advanced settings here, and we want to set CCD as true and multi-body overlap as true. And that's all we need to do for the actual physics settings on our hands for now. So I want you to just compile that as well. Now we need to set up our physics constraint actors for the right and left hand. Good news is both the values are the same, so we can edit them all together. One last thing we do on these physics hands, respectively, is what I want you to do is go down to the physics settings for each hand. I want you to open up this little advanced tab here, and I want you to scroll all the way down to physics asset override. For the physics asset override, this basically sets and ensures that the physics asset that we assign to our skeletal mesh actors is actually being used in the pawn as well. So for the right hand, we're going to go to this physics asset override, which is in the advanced section of our physics settings, and we're going to click on that, and we're looking for the right physics, and that's the physics asset that we created. And then we're going to go to the components tab, we're going to find our left hand, and we're going to set the left respectively. So now we have set the proper physics actors to our skeletal mesh assets inside of our pawn. So compile that, and now we can create our physics constraints. So to create the physics constraints, we're going to go back up to our right motion controller grip where our hand right tracking and hand left tracking are respectively. And so we'll start with the motion controller right grip. So you're just going to right click on that, or sorry, you're just going to click on that and then go to add, and then you're going to type physics constraint. And we want to do a physics constraint component. A lot of times people for this kind of tutorial use a physics handle, and I don't like how that works. So I use a physics constraint instead because it just feels better. It can be a little jiggly, but we've configured the settings so that they work pretty well, and you'll be able to play around with those values yourself. So for the right controller, it's going to be called constraint _ R. And then for the left hand, we'll do the same thing. Add physics constraint. And we'll call this constraint _ L. Okay, now what I want you to do is click on both of these so that we have them both selected, and we're going to set our settings for our physics constraints. So we're going to start out with our linear limits. Basically, these are set to log right now, and we actually want them to be set to limited. So go to this section here, make sure both of your constraints are selected, so we're editing both of them. Click limited on all 3 axes, and then we're also going to set the limit amount to 90. This value works the best, and then we're going to go down to our angular limits. Now these we lock fully because we want the physics hand to always match the rotation of our tracking hand and do its best to manipulate into that position when it can. And then we're going to go down to our linear motor, and we need to check all of these axes so that we're controlling how they work. And for the linear motor, you're going to want to play around with these values, but I've found that the best is 20,000. 20,000, enter. Okay. And then we also want to set our velocity target. So we check all 3 axes for this as well. And for this, I like to set it to be like 200. And again, you can play around with these values to get the actual physics feel that you want. These are just the most realistic that I've found from playing around with it a ton. Now we're going to go down to our angular motor, and right now it's set to slurp. We actually want to set it to twist and swing. And then we're going to check twist, swing, and twist, swing. And we set the first strength level to 500. And our second strength level, which is on the target velocity, to 50. And that is what we need for our hand physics constraints. So now that we have set up these physics constraints, we actually need to parent them to each of our tracking and physics hands respectively. So that's what we're going to do now. So I want you to unclick the toggling of both of these. So we're going to start with the right constraint, and we scroll all the way back up to the top in the settings here. And what you're going to see is we've got component name 1 and component name 2. So this is where we're going to be actually setting the constraint to its proper actors, right? So the constraint is like this little object here, and then we have our, tracking hand, which is here, and our physics hand, which is down here in the components tab. So I'll grab that one just to show you. So basically we need to make this connect the two of these things together so that we can track physics accurately. So I'm just going to move these around back into place so that we're not messing with stuff. And what I'm going to do is I'm going to take my hand-right tracking, make sure that that's there. I'm going to scroll to the top here of my constraint R because we're going to start with the right hand. And so the component 1 name is going to be our tracking hand. That's like the dominant thing that we need the physics hand to follow. Our component 2 name is going to be our physics hand, which is, you know, the physics hand. So basically you can go over here into the components tab, and if you press F2, you can change the name, but you're not going to change the name. You're just going to copy the name directly because this is case sensitive. We need to make sure that these two things match. So you've grabbed the hand right tracking and you're going to paste that into the component name 1. And then we're going to go down on the left-hand side here. We're going to find our hand right, which is our physics hand. We're going to do F2 on this as well. We're going to copy, and we're going to go back up to our constraint R, and we're going to paste that in. Now, one more thing that we need to do for these constraint names, or these like component names, is we actually need to give them a bone that we're parenting them to. So what we're going to do is we're going to go to our physics component, or actually no, we're going to go into our skeletal mesh component, and you're going to look for like what that root that we set the bone to, because this is going to propagate to all its children once we set up our master like physics asset. And so for the right hand, it's going to be hand underscore R, and for the left hand, it's going to be hand underscore L. So what we're going to do is go back into our VR pawn, and this is case sensitive as well, so you got to make sure that this is correct. We're going to do hand underscore R, and just copy that, paste it into the bottom. Okay, now we go to our constraint L. We need to do the same thing. So we're going to grab hand left tracking, F2, Control C, go back into our constraint, hand left tracking, go down, grab our left physics hand, F2, Control C, go back into our physics constraint, put that as component 2. And then for the bone names, we're going to do hand underscore L and hand underscore L. Right, we want to parent these two things together so that they're accurate. So now that we have set everything up inside of our VR pawn from like a very bare bones standpoint, we can actually test these out and see how our physics are looking. And this is where you're going to want to play around with the values to make sure everything is what you want it to be. So put on our headset. We're going to want to teleport over to like a wall or something and just push your hand against that. And you'll see that now the physics actor is reacting to the wall. So we can actually see like our tracking hand is going through this wall, and our physics hand is doing its best with, you know, the constraints that we've given it to not clip through everything. So, you know, a better example would be like right over here. I'm gonna go and just push my hand here, and you can actually see that now our right hand and left hand respectively have physics on them. But, you know, there's still more we need to do, because if we pick up like, you know, one of these actors, this should also have physics on it, but it doesn't. As well as, you know, our fingers are clipping through everything as well. And, you know, there's just stuff that we need to do to polish this up, which is what we're going to do for the second half of this tutorial. Now, if you were wanting to be done and you just wanted physics, you're done. But everything else after this is like polishing it up and making it an actual mechanic. We are now at the refining physics section of this tutorial, and to start we need to go back into our physics actors or physics assets and add all of the colliders and constraints that we need to be able to give each of the fingers their own realistic collisions. So let's start out with the right hand. I want to open that up, and with the physics asset there's a few things that we kind of need to like toggle visible so we can move stuff around. But to start, we need to go to this little gear icon in the upper left corner. We want to go show all bones, and we're going to scroll down to where our hand R bone is. So like, see, here are bones on the left hand side, and then here's like what the collider is. So we need to add colliders and constraints to all these bones, but we don't want to do it on every single one of these. We only want to do it on like the bones that actually matter, if that makes any sense. So like there's a lot of like little hidden bones inside of here that are not as important. Like we've got these metacarpal bones that do not need colliders on them, but like we do want them on, you know, like our index. So what we're going to do is we're going to grab our index 0, 1, 0, 2, and 0, 3. Then we're going to do the same thing for the rest of the fingers. So middle, we grab those 3 as well. We're going to grab the ones for the pinky. We're going to grab the ones for the ring finger, and then we're also going to grab the one for the thumbs. And then if we scroll down to the lower right here, for some reason this revision control is like kind of in the way of my thing. So like if you scroll down to the lower right here, you can see add bodies. We're actually going to do that. And what it's going to do is create a bunch of bodies and constraints. So the first thing we want to do is select all of the new physics constraints that we just created for this hand. So I will go and grab all of these and like see all of these like little constraints. We want to set these so that they are simulated. So we'll go over to the right hand side here after we've selected all of our constraints for each of the fingers. We're going to set them to simulated, and then we want to set their sleep family to sensitive, and that's done. And then we want to also show our constraints so that we can see them here too. And so for the ones that are actually on the hand, actually to make this a little easier, what I want to do is hide bones because I don't want to see them. I just want to see our constraints and our, you know, colliders that we've created. Right now we can't actually really see what we're doing because there's a bunch of these constraints that are just blown up and in our way. So we can go to character, constraints, draw constraints as points, so that will make them out of the way. And you can see it's generated a bunch of capsules for each of our fingers. So the first thing we want to do before we start messing with the constraints is actually change these capsules so that they are, you know, effectively arranged on the hands, because, you know, they're like too big, they're going to be colliding with each other, and it's going to be bad physics. So we'll start with each of these fingers, and I showed you how to adjust the one on the hand, so I'm going to speed up this process, otherwise this video is going to be like 2 hours long. So just do this to the best of your ability. You know, it's pretty simple. You're just rotating, moving, and scaling these to match the actual profile of the fingers, because that's what these are. They are the physics for our fingers. So, you know, do that at your own discretion. This is something that you have to tweak yourself anyway, because the way that I show you how to do it is really not going to be what you want. It's going to be how you want it to be done. So I'm going to speed this up. Now that is all of these capsules better aligned with what I want them to be on the hand. So now what I'm going to do is go over to the constraints, and I'm going to show the constraints. I'm going to hide the bodies. I'm then going to go back to the character. I'm going to turn off draw constraints as points. I'm going to go into each of these now and configure what settings I want them to be for, you know, how they're going to constrain. So like right now, basically what it is like we've got the colliders on the hands, right? And then there's constraints. Those are the joints in between each, you know, one of your bones on your finger, right? So like my finger, if I push it, it really can only go back this far. It shouldn't be able to just like completely flop. Now with these constraints unconformed, right, like when they look wrong, for example, if we wanted to simulate this, you can see that the hand just completely like mangles itself entirely. Like it looks terrible. And we're going to be like kind of giving these fingers a bit of a simulate on them. Like it's a very, you know, tame simulation, but we need to configure our constraints so that this doesn't happen when we enable those physics simulations, because we want the fingers to like somewhat conform around objects in our scene, right? So what we're going to do is, you know, configure these correctly. So for the joints, or sorry, for the constraints that are like on these parts of our fingers, right at the very base, we're going to set different settings than we are for the ones that are here, because these ones, you know, they don't go side, they only, you know, bend like this, whereas like these ones, they have a little bit more range of motion to them, and we need to configure that properly. So I'm going to show you how to do that and give you the proper settings that you need. We're going to select all of the ones that are like at these parts of our hands. So we're going to grab the hand R constraint. We're going to grab the middle R01 constraint. We're going to grab the pinky 01. We're going to grab the ring 01, and then finally the thumb 01, because these are all going to have the same constraint values so that they're correct. So what we're going to do is we're going to go down to this angular limits. Sorry, we're going to go to linear limits and keep them all locked. We're going to actually go into angular limits, and here we're going to set the proper constraints. So for the swing one motion, we want to set that to locked, so that we don't want it to go on the x-axis, or sorry, we don't want it to do the swing motion one at all. And then we're going to go to the swing two motion. We're going to set that to limited, and the twist motion is also set to limited because we don't want the fingers to be able to completely rotate around. And then for the swing two limit, what we're going to set that to is 30. And for the twist limit, we set that down to like 10 or, yeah, we're going to set it to 15 actually. Okay, so you can see these changed. You can actually see how they're going to be bending now. And this is like more accurate. Like the thumb does do this, but it also does this. And so we want to make sure our constraints allow it to do that. As for the, the fingers down the hand, we're going to select everything that we didn't select. So index 0, 1, and 0, 2, and then middle 0, 1, and 0, 2, and then pinky 0, 1, and 0, 2, and then ring 0, 1, and 0, 2, and then thumb 0, 1, and 0, 2. We're going to lock those constraints too. So we're going to go back down, and for this one, we actually lock. And so for these ones, we're actually going to lock both the swing 1 and 2, and the only thing that's going to be allowed on these are twist motions. So we're going to set that to limited, and then the twist motion that we're going to allow, right? So like, as you can see here, this is a little bit too much range of motion. This only can really bend like 15 degrees, I would say. And so now you can see we have a little bit more accurate twist motion allowing. And I'll just like select one of them so you can actually kind of see here what that looks like. So as you can see, we've got like a proper twist going on. And now if I were to go back and simulate, the hand is a little bit more realistic in how it's conforming around objects. So we're going to do this. We're going to go and do the same thing on the left hand now. And I'm going to show you how to do all of the settings in case you missed them, but then I'm going to speed up actually doing all of this work, and I want you to just copy the information here onto the left hand. So we'll close the right hand physics component because it is done. We're going to go back to our main project window. We're going to open the left hand asset. We're going to show all bones. We're going to select all of the bones in the hand that we care about. So middle 0, 1. So like every single finger that you have, the 0, 1 through 0, 3. So we'll select all of these. And now they have an L at the end of them because this is the left hand component. So finally the thumb, yep. We want to skip these metacarpals. We do not care about these metacarpal bones. And then we go down to the lower right where it says add bodies. We're going to click add bodies. And it's going to add bodies and constraints. I'm going to hide bones. I'm going to select all of my physics components here. I'm going to set them to simulated, and then I'm going to set them to sensitive. And then I'm going to go to my character. I'm going to go to my constraints. I'm going to draw constraints at this point so I can actually see what these colliders are doing. Oh my God, I don't know why it makes them look so shitty, but it is what it is. And I'm going to speed up turning these correct. And remember, you're just lining them up. It's eyeball value. There's really no perfect way to do this unless, your index is rotated like this, then you're, in the wrong. So go and fix these, and then we'll add the settings that we need to add for them. All right, now that our constraints are all in place, we can do now that our physics bodies are all set up correctly, we can go to our constraints and set those up as well, and then we'll do a test simulate to make sure that they look good. So we're going to show constraints. We're going to go to where it says show constraints as points again. Constraints, show constraints as points. We're going to get rid of that. And then we're going to go and grab all of our 0, 1 constraints first because we have to set those. Pinky 0, 1, ring 01 and thumb 01 constraint. We're going to set the twist 1 motion to locked. We're going to set the limited and twist to, sorry, we're going to set the swing 2 and twist motion to limited. We're going to set the twist 2 limit to 30 and the twist limit to 15. And remember, play around with these values if you don't like what I gave you, because, you know, it's kind of up to you to figure out what you want. If for any reason, by the way, while we're doing this, you like fly away off screen, you can just press F to refocus onto the asset. And now we're going to do the ones that we haven't touched. So I'm just going to actually hide the body so I can just see the constraints. We're going to select all of our 01 to 02 constraints. So we have those all selected. We're going to lock both our twist 1 and twist 2. We're going to set our twist motion to limited, and then we're going to set the twist limit to 15. And now we have set up the constraints properly on both of our hand meshes. We're just going to do a test simulate to make sure that works. As you can see, it's, you know, looking pretty realistic here. So we're going to stop that and we're going to save this out. And now we need to go into our project settings and configure the max physics substepping so that it can actually handle the amount of physics collisions it's going to have to compute in a given frame. This is performance intensive, by the way. So you're going to have to find ways to optimize your game or whatever game you're doing to account for this substepping, but it's the only way really to make your physics work correctly without welding physics assets together in C++, which I'm not going to do in a tutorial anytime soon, mostly because I don't actually have an effective way of doing it and teaching it to you, and also because it's kind of a pain in the ass to set up. But I'll show you how to do it this way, and this is pretty good. So what we're going to do is go to our project settings. So what we're going to do is we're going to go to our project settings, and we're going to go to all settings, and you just type in SUB stepping, so substepping, and then we're going to enable substepping. And then we have to set these values to account for what we're trying to do. So we're going to set the max substep delta time to 0.005, 0.005, Unreal, you better cooperate. And then we're going to set the max substep amount from 6 to 10. This gives the engine a little bit more breathing room to work with when it comes to actually like computing all of the collision values that it needs to be computing. And gives us the opportunity to be able to have like per body collision on a single skeletal mesh actor. Okay, so now we have that. We need to go into our VR pawn and actually set it up so that the hand bone from the constraint propagates all of the collision values to its children, because all of the bodies that we just created on both of our hands are actually children of that original hand constraint mesh. Body. Jesus. So we're going to go into our event graph. We're going to scroll way to the end of our event begin play event. So what we're going to do is we're not actually going to put anything here quite yet. We're actually going to go over to the functions tab on the left hand side here. We're going to create a new function, and this function is going to be called setup bone physics and weight. Make sure that you spell weight correctly, because if you don't, people on YouTube are going to make fun of you. Weight. It's a stupid word. I hate that word. Anyway, we're going to create some events here, and we're going to make this a function so that we can easily propagate it to both hands without too much like annoying input. And I'm going to show you exactly how to do that. So first, we're going to drag off of this execution pin. We're going to create a node that is called set all bodies below simulate physics. It's going to try and give it like a descriptor here, so you can drag that in, but I want you to actually disconnect handwrite from this, and I want you to drag it down to the left here. And then I want you to pull off of this bone name, and I want you to write make literal name. And then that plugs actually into this event, our function start. And right now it just comes in as value because it's like a string value or a name variable. You're going to change this to root bone name. Yeah. Okay. And then you're going to check new simulate and include self in that new simulation, and kind of drag this out to make a little bit of room so we can plug something into it. And right now we have the hand right getter. We also want to go down to our components tab on the left-hand side here and drag out a reference to our hand left as well, because we're going to reference both of these things. And what we're going to do in order to make sure that these events are firing correctly is we're going to create a select node. And this basically allows us to connect up an enum, so that way we can just drag this function into our graph anywhere and then select which hand we want it to fire on without having to drag in the function and the getter node, so that it can, it just kind of pollutes the graph with a bunch of stuff we don't need it to. So what we're going to do is plug in this return value to the target, and then now it turns these pins blue. And so we're going to take where it says index, we're going to actually click on this, and we're going to type hand. And if you followed my procedural hand tutorial, you're going to see an enum down here that says hand. If you didn't follow my procedural grip tutorial, you're not going to see this hand enum. So I'm just going to show you how to create it quick, because I don't want anyone to not be able to do this tutorial. Basically what you're going to do is you're going to go into the blueprints tab of the VR pawn. You're going to type enum, and you're going to create an enumeration. And so inside of that enumeration, you're just going to create 3 enumerators. One will be left, one will be right, and one will be no hand. This comes into play in the procedural grip tutorial for how we determine what an object is and what hand is grabbing it. But I just wanted you to be aware that this exists, and here it is. So that being said, back to what we were doing inside the pawn, we're going to grab that, we're going to type hand, and we're going to grab our enumerator, and what that does is it gives us exactly what's inside that enumeration so we can select. And so the hand left is going to go into the left pin, and the hand right is going to go into the right pin. And then we're also going to drag off of this set all bodies below simulate physics. We're going to do set all bodies below physics and blend weight. And it's just going to pull a getter for the hand left. You're going to just delete that getter, and now you're going to plug the return value of the select node directly into that. What we're going to see down here is a few options. You're going to have include self on, but for this physics blend weight, this is a variable that actually controls how much we're using our animations of the hands, and then the actual physics simulation on each of the fingers with those constraints we set up in the physics actor. So what we want to do is go to the left-hand side here, and we're going to create a new variable. So if we scroll down here, we're going to set this variable to be physics blend weight, and this is going to be the global physics blend weight for all of our fingers. So we'll do physics blend weight. Set that to be float, and then for starters, the best value to set for this specific variable, in my opinion, is 0.15, and this is just basically 0 would be its all animation, and 1 would be its fully physics. And we can kind of play around with this, but for now, what we're going to do is set it at 0.15, and then we're going to take this, and we're going to plug this directly into our setup bone physics and weight, and then we'll connect the make literal name to the in bone name, and we'll compile. And then here we have a fully set up function that we can now use. Yep. So this is correct. That's there. We're going to go back to the event graph, and we're going to scroll to the end of the event begin play function. We're going to drag out our setup bone physics and weight function, and we're going to connect that up. And so for the first one, we'll do the right hand. So, whoa, shit, we forgot something. We need to drag out this index in here too, so that way we can set it for each hand. So we'll just call this hand. Okay, save, go back to the event graph. Now you will see that that is populated, so we'll do it for the right hand first. So we'll do hand underscore R. Make sure that this is correct. It needs to be case sensitive. And then we'll drag out our physics blend weight node and plug that right in here. We'll drag that forward a little bit. Yep. And then we'll just grab this, Control C and Control V. Connect that up like so. Also, I want to make this variable editable, and also set it to the hand physics category. which you just type into the category right there, and now it'll appear in its own category. But we'll make it editable so we can grab the pawn if we need to and just change it like so. So then we set that to the left hand, and we do hand underscore L, compile and save that. Now that we've set up the physics blend weight, we could test, but we actually need to restart the engine in order for our like Physics-Substepping stuff that we set to actually take effect. So what we're going to do is we're going to close this engine, save everything, and then we're going to go back to our procedural grip demo project. We're going to drag that back in to our Unreal Engine launcher desktop thing. So now that our file's back open, I just want to illustrate what the physics blend variable actually does. So just for fun, I want you to test this out. We're going to go into this physics blend weight variable. We'll just grab the one in the hands physics category here. And we're going to set it to 0. We're going to set it to 1, and this will be like full physics blend weight. And just to kind of like better illustrate this, I also want to go find our tracking hands. And we're going to set these both to be hidden in game. So hidden in game. There we go. Okay, so save these, go back out, and press play, and just put on your headset and pick up your controller so you can see what this does. So as you can see, if we set our physics blend weight to 1, all of our fingers are like very much like wiggly little jello-y things. And this is not what we're looking for if we want like realistic and good hand physics, right? So that physics blend weight variable basically allows us to set the value. So what we want to do is set it to 1.5 because that seems to just be the best thing for it. Also, make sure to turn these back to not hidden in game so we can see them still. But just go back to the physics blend weight variable, and in the default value, set this to 0.15 because that is, you know, a good balance. So we'll save that. And now let's test out our hands with the new physics and the fingers. So when we teleport up, our hands like shoot forward and just smash the blocks, which is just like a bug that we're gonna fix as well. It has to do with the teleportation. But like, as you can see here, like down here, this is working like relatively well for how these are going. You know, I kind of still wish that they were like, you know, better, but for the most part, like especially if we come over here, we can kind of see that like this looks pretty decent. And right now we don't have any collisions on the object itself, so it just comes away with the tracking hand. So we're gonna need to do a few things. We have to set these objects so that they latch onto the collision of the tracking hand, and then these, you know, conform correctly. And then we also need to fix this teleportation issue that we're having, where if I like go teleport back here and then I teleport forward, you can actually see that the hands just shoot into the blocks and destroy them. So that's what we're gonna fix next. I think I want to start out with creating the events that allow us to pause the hand physics when we're teleporting and when we're snap turning. Then I'm also going to show you a fix I found for the snap turn, because I don't know if you noticed, but if you try to like snap turn right and left, it just completely breaks. So let's go over to this event in the VR pawn. So go into the VR pawn and go to this event. Also, sorry that my dog is sitting on my lap. She's really needy and wants attention, so I'm just gonna let her sit here until she gets bored, and then I'll put her down. But what we need to do is create a do once here. So you're gonna pull off of the triggered here, and you're gonna do a do once node. And then you connect up the reset to completed. And this is going to fix the issue where the snap turn only works on the right side. And so you're just rotating around in one direction. Basically, there's something up with this version of Unreal where it's not giving you what you need. But we do need to create another function, and this function will be called pause hand physics. So what we're gonna do is we're gonna go to our functions tab on the left-hand side here, and we're gonna, no, don't sniff the microphone. We're going to create a function. We're going to call it pause hand physics. And then we're going to build this function so that it works for us. So the first thing we're going to do with the pause hand physics function is we're going to drag off from this execution pin. We're going to create a branch. And then we're going to drag the condition of this branch directly into the pause hand physics function header. And we're going to call this Boolean variable enable simulation, and then put a question mark on it because it is a variable. And so basically, like, this will allow us to say whether or not we want to like enable simulation, and that'll actually help us pause the hand physics. And then we need to go off of the true first. We're going to drag out and we're going to do set all bodies below simulate physics. It's going to pull out a getter for the hand right, and we're going to do that select thing that we did in the last function we created. So just for now, I want you to drag this down here. And what I want you to do is set this node to new simulate. You're going to set new simulate on this Boolean, and then you're actually going to Control C and Control V this, and then this is going to connect up to the false. So basically, when it's being set, we can toggle it. Essentially, it's like a toggle. And then we're going to drag off of this in-bone name, and we're going to type make literal name. That way we can tell it for each hand, and we'll drag that into both sides of this, and then we drag that value directly into the pause hand physics, and then we call this value root bone name, and then we're going to ignore that for now. It's just an error because we have nothing set to the target. We're then going to drag off of the set all bodies below simulate physics on the top from the true, and we're going to do set all bodies below simulate physics. Sorry, set all bodies below physics blend. Wait, and grab the hand left versions because that way we don't have to like drag it out from the thing. And so what you're going to do is you're going to pull this hand left back here above the right, and then right here we're going to connect the in-bone name up to this make literal name. But to make it easier and a little bit more organized, we're just going to double click on this path here, and alt click there and drag this out. And then we're going to drag this into the make literal name string. Kind of see how this is coming together. And then you set include self on that one as well, but do not set skip custom physics type. And then we're going to grab this, we're going to Control C, we're going to Control V below, and we're going to drag that into the execution bin coming out of the false. And then we're going to select the make literal bone name string and put that into the in bone name. And then for these two set physics blend weights, we actually want to set the top one. So we're going to go find our set physics blend weight here, and we're going to put that in the top. And then for the bottom one, we actually just leave physics blend weight at 0 because it's going to be fully driven by animation. And then from here, what we're going to do is for the top, we're going to do detach from component. So for here, we want to do keep world, and keep world, and then leave the column modify as true. And then for the bottom one, we're going to do attach component to component. Okay. And so what this is doing is whenever we're pausing hand physics, we're going to turn the constraint off, and we're going to attach the physics hand directly to the tracking hand and then disable else physics. So that way, like when we're teleporting or doing a snap turn, or we're jumping or falling or like sprinting or something, and we don't need the hands to actually interact with the environment that much, we can just turn it off. So for this one, like for the values, what do you want? Stop it. All right. So for this one, we set the location rule to snap to target. So it's like attaching. But for the rotation rule, we're going to do keep world. And for the scale rule, we're going to do keep world because we don't want it changing. And then we're also going to leave weld simulated bodies checked. This also is going to come in a little bit later. And then for the socket name, what we're going to do is we're going to drag off, and we're going to select the make literal name string that's coming from our setter. Okay, so now we have pretty much everything set up. We just have to set up the dependencies because all of these targets have no values. So what we're going to do is we're going to go back to our hand left and hand right, and then we're actually going to drag out another reference to our hand right tracking and our hand left tracking. We're going to drag these on top of each other. We're going to create 2 select nodes. So right click on the graph, type select, and then just grab this and copy it. And so for both, we're going to set the hand enum. So set hand. And for this one, we're going to grab and drag up into the main thing. We're going to set this variable name to be hand. And then we actually do the same thing for this one. So we just connect it into that one. So we don't have to do anything else special. And so now we need to actually figure out which is going to which. So for the physics hands, these are going to go to this top one. So hand left and hand right. These are our physics hands. So they're going to go into anything having to do with physics. So we're going to use that for the set all bodies below simulate physics and set all bodies below simulate physics. And actually I want to just double click here and create like a path for it. Below the make little string node, we'll press Alt here, pull into both, and then the same thing for setting their blend weights. So we'll go into the top one, we'll double click and drag it down, and then we'll connect that to the bottom one. And then so for here, it gets a little tricky because this is the target for both of these, but the tracking hand is actually the parent for the attached component to component. So you're going to connect this up to the target, and so this is the one coming from the select node. It goes through, it connects to both of these, and then both of these, and then it connects to both of these in the target location, but we still need to set a parent, basically what we're telling the physics hand to connect to. And that's where this select node comes in. So we'll drag in the hand left tracking up here and the hand right tracking right here. And then this one goes all the way over here to the parent. And at the end, it should look like this. Now we'll compile, those errors will disappear because now we've set dependencies, and we can now use this function in different parts of our graph when we need to turn off physics. Especially if you're doing like story events, you can just use this event to turn physics off if you need to. So let's go and put that in practice. We'll start with actually our snap turn, and as you can see, we've actually fixed snap turn. If you want to go test it out now, you can see that it snap turns correctly. But what we need to do is drag in a function, the one that we just created, to actually pause the hand physics whenever we are, snap turning. So we toggle it off, and then we go and toggle it on. So what we're gonna do is we're gonna make some room here. We're gonna drag out some space. I'm gonna Alt click on both of these to give me a better, more room to work here. And I'm gonna copy these twice. So I'm doing one of these functions for each hand. So I'll do the right hand first. I don't know why. I want the right to be first always. And then, so for the root bone name, I'm going to set it to be Control A, delete, hand _R. And for the root bone name on the left, I'm going to do hand _L. And then I have these set correctly. And then for here, we leave the enable simulation boolean unchecked because we're telling it not to simulate and instead to attach it to the tracking hand. So that's going to come off of triggered and connect right into pause hand physics. And then we're going to drag that into the do once. Yeah. And then on the completed, we're going to Control C, Control V both of these below each other. And then for these, we actually enable simulation. And we connect the completed up to this bottom one. And now that I'm thinking about it, the triggered, we actually don't want to just constantly run these if you're holding it down. So we're actually going to take the do once and we're going to drag it before these two things. So basically, it pauses hand physics after it's decided where it's going and then connects up to the rest of the function for snap turn. So we'll drag that out, push it over, drag this down to make some more room. So this unsets the physics, and then this one down here will reset the physics and then also just reset the do once so that you can continue to use snap turn. So let's go see that in practice. And then we'll snap turn. See how the hands now don't freak out when we snap turn? It's kind of what I'm going for. But as you can see, if we teleport, they still freak out. So now we have to do a similar thing for teleportation. So now what we're gonna do is add the same stop physics functionality to our teleport So the first thing we do is go here into the input action move teleport feature. We're going to drag out this to give us some space. And you can see we've got end teleport trace and try teleport. That's what happens when we like stop the trace and we finally go. And that's where most of our code is going to go. So what we're going to do is after the end teleport trace, we're going to drag this out to make some more room. We're going to get rid of this. What we're going to do is copy paste these two functions up here down below, because we don't want to have to just like write them all out again, except we're going to disable simulation. So we'll drag, I accidentally copied this comment. We're going to drag these two into place here right after the end teleport trace. So we disable simulation here, and then we connect that up to try teleport, but this would just leave it off fully. So what we need to do is add a delay node for about 0.2 seconds. And that gives it time to, finish teleporting before we turn physics back on. So then we go and we reactivate our physics after we're done teleporting. So this delay, we might have to tweak a bit. I think 0.2 seconds is the amount we want it to be, but just in case I'm wrong, we'll come back and fix it. So now we'll go and put our headset back on, and we're gonna go teleport up to these cubes, and that fixes that explosion issue. So if we look down at the hands when we're actually teleporting, you can kind of see it just sets them to the hands. We teleport, and then it sets them back. The final thing that we need to do for this tutorial to be finished is make it so that when we go and pick up an object, it doesn't phase through the environment. We want the hand and the object that the hand picks up to inherit the physics that we've applied to the hand. And it's actually pretty simple how we do that. We're gonna need to go into the grab component. Now, if you have followed my procedural grip tutorial, you're gonna see something in here that casts the VR pawn and it sets a VR pawn reference. We need this in order to actually do the code that we need to do. So make sure that you do this if you didn't follow my procedural grip tutorial, because it'll be kind of like hard for you if it doesn't. There's another thing that is also inside of this that was created in my procedural grip tutorial, and that was this macro right here, which is get hand from motion source. Essentially, it just takes a motion controller input and it figures out which hand is actually grabbing an object. So just recreate those two things I just showed you. You might have to like pause the video and rewind, but go do that because we're going to need to create a new macro, and then we're going to drag in some new functionality into our project. But the other thing is like this is just going to be difficult off the basis of the fact that I also set up in the VR pawn here 2 components. So if we go down to the left hand side inside of the VR pawn, we can see a held component left and held component right. But then we also up here have, so yeah, if we go into the procedural fingers, you can see right primitive component and left primitive component. What these are just primitive component getter nodes, and we use it to set the object. Like the object that we're picking up is the primitive component. So inside of the grab component, if we go to try grab, for instance, you can actually see that we use that get hand from motion source when we pull off of the, like which hand is grabbing for snap and free grab. And then we determine which hand is grabbing it, and then we use that hand to set the primitive component both in the pawn and in here, and then that goes forward to the animation blueprint to set the proper grabbing data. So I'm just going to leave this on screen for a second. If you didn't follow my procedural grip tutorial, you have to copy this. So make sure you set that all up correctly, and I've showed you the macro, I've showed you where the variables are inside of the VR pawn, and I've shown you how to make a reference to the VR pawn, so you should have everything you need to catch up. But if you already did all that, this stuff would already be in here, because you did it already. So what we're actually concerned with is actually at the end here. After we do these 2 events where we're basically like picking stuff up and like setting our procedural grip stuff, we also need to set it so that instead of attaching the object to the motion controller, we need to be attaching it to the actual physics hand. Otherwise, it'll just phase through objects with our tracking hand. So the first thing that we're going to do in here is we're going to get a reference to our VR pawn. So we're going to go to the left-hand side where we see components where we created that VR pawn getter, and we're going to drag that out and say get VR pawn. And remember, this will already be created if you follow the procedural grip tutorial. So if it's not there and you didn't follow the procedural grip tutorial, that's why. And you're going to drag out, and you're going to also drag out the macro, which is get hand from motion source. And for the motion controller input here, we're actually going to go all the way back to our motion controller function right here. That's like where it's like setting everything, and that's where the attached parent to motion controller is. We're going to grab that, and then we're going to bring that down over here. and we're going to plug that into motion controller, and then just double click this here to drag it down so it's not going through our other functions, and we can still read this code, and drag that down over here so it's nice and organized. So if you zoom out, basically what we've done is we've taken this motion controller get reference, we've plugged it into our get hand from motion source. That's how we set which hand is picking up the object that we need to weld the physics to. And then the next part, we're actually going to create a new macro, which is called attach parent to hand. Nice thing is that there's actually already some setup that we can use directly in order to make this macro. So what we're gonna do is we're gonna go to this macro that says attach parent to motion controller. We're gonna right click on that and we're gonna press duplicate. And we're gonna call this attach parent to hand. So instead of attaching it to the motion controller, we're attaching it to the hand. And we're gonna need to change some things around in here. What we're gonna do is we're gonna drag this out like so to give us some more room, because we're gonna need to set some different things inside of here. And the first thing that we're gonna do is we're going to create another input inside of this. In fact, actually, we're going to get rid of an input in here. So what we're gonna do is we're gonna X that right here where it says motion controller, just click the little X next to it to get rid of it. And instead, we're going to create a reference to the VR pawn. So what we're gonna do is go VR pawn, and see it says here, like you can actually see the object type VR pawn here, and that is our VR pawn itself. You're gonna type object reference, right? And then you're just gonna call this VR pawn. It's what we're gonna connect this VR pawn getter to once we drag this macro in. And then from that VR pawn, what you're gonna do is you're gonna pull out and you're gonna do hand right and hand left. You're gonna drag those out next to each other right here. And then we also need to add another input in here, which is an enumerator, which is our hand enumerator, which I already went through how to create that earlier, but if you followed the procedural grip tutorial, it's already inside of your project. So just type hand, drag that in. So now we have this parameter for hand, and you just label it hand so we can see what it is. And then we're actually gonna go back out and connect these things up now. So we'll go to try grab. We're going to drag out our attach parent to hand. It's gonna show up like right here. We're gonna pull off of elf trace finger data and our trace finger data and plug that right into this attach parent to hand. If you didn't do the procedural grip tutorial, you're gonna actually pull off from the is held and is held booleans, because this code here will not exist. Anyway, you're then going to take the get hand from motion source and you're gonna plug that into the hand. Okay, I messed up. So actually this is not called hand. You add another enumerator, and instead of hand, it's E controller. E controller hand, this one. That's what we want. And you set that to hand. This will not connect up correctly unless that's set to hand. So you're gonna do HAND. Oh my God, this is so annoying. Sorry. Go back in here. Now that you've unconnected that, you can go hand. Sometimes Unreal is just so frustrating. Okay, cool. Now that we have hand, like actually set correctly with E controller hand in the enum, we can go back out to try grab. We can connect up the hand to the selection, and then we can connect up the VR pawn to VR pawn. Now all of our references will be set, so once we code the attach parent to hand code inside of here, everything will work correctly. So just make a little comment here. Attaches, pick up object to hand dead of motion controller. Now we could go back in and re-edit this to do what we're doing here, but I just found it easier to put it at the end. But if you wanted this to be cleaner and not fire events that don't matter, you can go back and fix this. I'm not going to though. And then just make this like blue so we know that we made it and not Unreal made it. Cool. And then we're going to set that there. We're gonna go back inside of our attach parent to motion controller and we're gonna go back to attach parent to hand, the macro that we're actively working on, and we're gonna set this up correctly. So one thing we're gonna do is I just wanna drag this out a bit, and then we're actually going to duplicate this branch and copy it below because we need to do this for both hands. And then what we're gonna do is drag out of our hand here, and we're gonna type switch on E controller hand. We're gonna plug that into the execution pin. Now we're gonna do this for the right and the left hand. So for the right, we'll plug that into here, And then for the parent, we're going to connect up the attach parent right here. So that's going to actually now go into the, sorry, my bad. So we're gonna pull off of this hand right getter and we're gonna connect that to the parent because that is now the parent. And then we set this all to keep world, except we weld simulated bodies because we want it to stay as so. And then we're actually going to grab this and we're gonna copy it beneath, because what we need to do now is do the same thing for the left. So what we're gonna do is we're gonna grab the hand left and we're gonna connect that up to the parent, and then we connect up the attach parent to the target. And the attach parent, by the way, is what we're grabbing here. And then we're going to pull off of the left on the switch on E controller hand and connect that up to attach component to component. And then we connect that up to the branch. Now for this branch, the return value, we just connect to true and false. Basically this, if for some reason the attach parent is invalid, we'll basically get this print string that'll tell us that it failed. And then we're just going to double click these two things, and the true will go to this top one and the false will go to this bottom one. So now basically what we're doing is whenever you pick up an object, it decides which hand to attach it to, and then it welds the simulated bodies of both collisions directly to the physics hand. So when we pick up an object, when we pick up an object, that object will inherit the physics of the hand and react accordingly. So we can actually go and test that out right now. Okay, so let's teleport forward. I'm just gonna grab this sphere. Never mind, I'm gonna grab this pickup cube. And then I'm going to push my hand into this bench here. And as you can see now, because of the work we've done just now, the object now inherits, whatever we wanted it to. So if I just go and restart this again, because I want to see it on a different object, you can go pick up this cone that I put into the sample project, and we can take it on the end here. You can actually see how it conforms around this corner accurately, and we can drag it along if we want to, so that it is interacting with the physics. And then obviously it works on these things too, and then we can swipe stuff as well. My mic's kind of in my way, so it's harder for me to illustrate this, but you get what I'm trying to say. Now we have a few final things of polish and then one debug thing I want to add because it's just really useful. The first one is going to be toggling the hands off when you open the VR menu. And this is just something that, makes it nice if you really want to see the tracking hands versus the non-tracking hands. And then also adding animation onto the tracking hands so that they function correctly. Now, we're going to go down to the input menu toggle left and input menu toggle right. And what we're going to do is create a new function that we're going to insert into here. That's going to allow us to turn the hands invisible and then turn the tracking hands visible. So what we're going to do is we're going to grab hand right and hand left tracking, and we're going to finally turn these hidden in game and set that up like so. And then we're going to create a macro. So we're going to go to the left-hand side here. We're going to click plus for a new macro. We're going to call this toggle hand visibility. Okay, and then we're going to add two inputs to this. 1, 2. Sorry, we'll add 1, and then this one will be toggle tracking hand, and then the next one will be toggle physics hand. And then what we're going to do is drag this over a little bit to give ourselves some more room. We're going to add 2 more inputs. The first one will be a Boolean, and this is hide physics hands. Basically, this just gives us the option if we want to either hide or not hide the physics hands. And then we're going to create another one, which is the enumerator for our hand. So we're going to go hand enum. Sorry, just type hand. It'll be right here. And then you're going to call this hand. Pretty simple. And what you're going to do is drag in getters for our, let's just type in hand. We're going to drag in a getter for our hand right tracking. We're going to drag in a getter for our hand left tracking. And then we're going to drag in a getter for our hand right and our hand left. And then the reason we're doing this is because we're going to do that select node thing that we've been doing. So what we're going to do is drag our hand right over here, like our physics hands over here, and then our tracking hands right here, and then put the right below it just to make it easier to understand. We're going to type out a select, and we're going to plug the index into the hand. Then we're going to plug the left into the left and the right into the right. And then we're going to do the same exact thing for the physics hands. So just drag out from here, type select, connect the index up first, double click this to make it look a little cleaner, drag the hand right into the right, drag the hand left on top of the right, drag that into left. And then from the select for the, the tracking hands, you're going to drag up and you're going to go set hidden in game. And this one is going to be new hidden is going to be false. You're going to connect that up to toggle tracking hand. And then what you're going to do is you're going to drag out of the hide physics hands here, and you're going to create a branch. And you're going to connect up the toggle physics hand. Sorry. You're going to double click here and then double click again to drag this up above, because we're going to check it on both sides. So drag this down and make it look prettier. Drag this over, and then we're going to grab this again, and we're going to copy paste it below. And we're going to type, for this one's going to go down to toggle physics hand right here, and this one will be new hidden, and it'll be true. So basically what happens is when we press the menu button, we're going to turn the tracking hand visible and the physics hand invisible. Then we're going to check whether or not we actually wanted the physics hand to turn invisible, because if we didn't, then we just skip the toggling of this entirely, because the next part what we're going to do is we're going to toggle the physics hands invisible and visible. So what we do is we just copy paste both of these two things over to the right, drag these in like so, false and true. You're going to connect up the hand left and right to these two here, and then for the physics hand on the top, it's going to be new hidden is checked true, and on the bottom it'll be new hidden is checked false. And then we add two outputs on our output. So the first one will be A. First one will be A, and then our second one will be B. And then we plug in the A from the top and the B from the bottom. Now what we're going to do is go back to our event graph, because we have finished this function, and we're going to use it in these two events. So from this started, we're going to go toggle menu. That will always happen. And then we're going to pull off of that and type flip-flop. So basically every other time this will switch directions. So it's basically a toggle. And then what we're going to do is we're going to drag out the toggle hand visibility macro that we created, and plug the A into the toggle tracking hand and the B into the toggle physics hand. We're going to set it to be the right hand first, and then we're going to set hide physics hand to true, because when we open the menu, we want the physics hands to be hidden. And then we're going to duplicate this one, move it forward, connect A to A and B to B. This one will now be our left hand, and we also hide physics for that. And then we go over here to the other input action menu toggle, and we're just going to grab all of this code, and we're going to paste it over here as well, drag that up and connect it as well, and then just change this so that it has all the code inside of it. So now make sure that you connect the return value to the set hidden in game second target too. Okay, now this should totally work. So as you can see, our tracking hands are now disabled because we set them hidden by default. And if we press the menu button on the left hand, it turns our physics hand invisible. And so now we can interact with the menu with our tracking hands. And then if we turn this off again, our physics hands are back. And so now we have physics hands that can interact with everything. And then if we turn on the menu, it's our tracking hands again. And then the last thing I want us to do, just in case you're having any issues with your physics, because I've noticed a few bugs with this physics system, and like the only way I could fix it was by creating some sort of debug, is actually to create a custom event that allows us to turn on physics visualization for our pawn and the world around it. It helps with like, you know, debugging physics problems. So what we're going to do is we're going to scroll to the very top of our VR pawn blueprint. We're going to type add custom event, and then this event will be called toggle collision visualization. We're going to drag off of this and we're going to do flip-flop. And then we're going to drag off of this and type execute console command. And basically this allows us to execute specific console commands that we need for, you know, visualization purposes and other things. Okay, and so for this one, we're gonna just type show in lowercase, a space, and then in all caps, collision. And this needs to be exactly correct. This is case sensitive. So now that we've done that, we just copy paste. Compile first, then copy paste. Sometimes I've noticed this bug with Unreal where like it doesn't let me like do stuff. So I just close the pawn, and then when I go reopen it again, it lets me. There we go, and then connect B to the B on the show collision. Now if we save and compile, this now exists inside of our VR pawn. So what we want to do is we want to go over to our menu blueprint, which is right here, and we're going to, sorry, that's the wrong one. We're actually looking for the widget itself. So in the widget menu blueprint right here, we're going to go inside of here, and you can see that we have the menu that comes up when we press the start button. What we're going to do is we're going to grab this exit button here, and we're just going to duplicate it. And what that does is it creates an equal button directly below it. So what we want to do is we're going to grab the text for this button first, and over here where it says real life, we're going to actually change this to be toggle collision viz. And then we're going to change the name of this button. So you're just going to go over here to the left-hand side in the widget menu, and you're going to type out, in the hierarchy, and you're just going to type call debug. And that allows it to be a variable that we can use in the graph. So now we go over to the graph, and right now we don't have any way of actually like pulling events from the pawn. So what we're going to do is we're going to drag off of this event construct, and we're going to go cast to VR pawn. And then we need to reference this with an actionable object. So we're going to do get player pawn. And then from there, we're going to right click on this as VR pawn, promote to variable, and create a variable for the VR pawn. And just change this name to VR pawn ref. And now, if we grab our cull debug button, we can see on the events on the left-hand side here, we can see one that says on clicked. You're just going to click on clicked, and it creates a new on clicked event right here. And you're just going to drag off of this. Sorry, actually, you're going to drag out a reference to the VR pawn, and then you're going to type out the event that we called it. So this would be toggle collision visualization, and then you just connect that straight up to the on clicked event for this. So what this is going to do is when we go into our game and we press play. So if we press the start button, we can see that this button is now here on the screen. So if we turn that on, we can now actually see all of our colliders on our hands, as well as all the colliders within the world. So like if we look over here, we can actually see, you know, let's say we're having like bugs of some sort, like, I don't know. For example, like a good example would be like for example, we have an issue, I think here, where like some of these fingers are not colliding correctly. We can go in and we can change different physics settings in the hands. But for now, like this is working pretty well. And a lot of what we would need to do is actually create some events for, you know, making the physics hands more reactive to when they collide with something. And that would be a very complex function that I'm still configuring right now. But for the most part, at a high level, you know, this is hand physics as it should be. And if you just want to turn that debug off, now we're back to normal. So finally, what we can do is fix the fact that our tracking hands, when we're in the menu, don't actually have any animations on them, because we need to link them up to these events down here. So what we're going to do is we're going to create some more space. We're going to drag this comment out. So what we're going to do is we're going to drag this event over. So like these are all of our like pointer, grip, grasp animations. We want our our hand to replicate these. And then what we're gonna do is we're going to grab this stuff right here where it says like get hand animation instance, all this stuff. We're gonna Control C this, and we're gonna copy it to the right here. So just copy it over, and you'll see that it's all disconnected. And we need to actually connect up our different hands to them. So this is the left one. So what we're gonna do is we're going to drag in a reference to our left tracking hand, and then connect this up to all of the get anim instances of these events, like so. And then you're going to connect the green strings from these events at the top, these two at the top here, to their respective strings over here. This is the axis value of the input action. Then finally, you complete the function. So when we are using our tracking hands and they are visible, we'll be running this over to the animation blueprint, so that way the tracking hand follows the animations of our other hand. And then I'm just gonna speed up doing this for the other side. All right, now that we have fully connected up our highlight values to the things, we can go and test this out. So basically, now I can like point with my pointer finger and turn everything on. I can turn my collisions back on, and then if I want to turn them off, I can do so. And then, looks like I've encountered a bug where you can accidentally swap them out. It looks like one bug I've encountered right now is that if I like press this button and then I end it with the other button, it doesn't turn it back off. And that has to do with, you know, having a button for the menu on the right and left hand. In reality, in a game, you wouldn't actually have that. However, it does kind of bother me, so I'll have to fix it in a short because I don't have the time to fix it right now. So I'll take a look at it. I'll post a short talking about how to fix it. Anyway, there's one last thing I want to show you guys. And this is kind of specifically for the people that followed my thumbstick tutorial, because there is code we need to add to the thumbstick code in order to make it so the hands don't freak out when you're sprinting. And what that looks like, I'm going to drag in my other project that's got all of this code together, is on the sprint functionality with stamina depletion. What you're going to do is when you start sprinting, off of the started, you're going to use the pause hand physics to disable collision. And then when you're done sprinting, you just re-enable it. And that looks like this. I will actually post a link to this image for those of you who did my thumbstick locomotion tutorial, so that way you can have everything working correctly as it should be. But let's go through and look at everything that we've created. So from a high level, we now have tracking hands and physics hands that we can switch between when we open the menu. We can turn on collision debug to actually look at these things. If we then teleport over to the table and interact with different objects, we can see that we're now pushing through the objects when we want to pick them up. We can now pick up objects and they will directly interact with the physics of the environment. So, you know, both physics and non-physics objects now react accordingly. So if I take these two things and I push them together, we can see that they now resist each other using the physics code that we programmed in. It's pretty robust. This system is pretty performant, it just works quite well. And then obviously, we can hit shit around now, and we can interact with things, and we have more realistic, modern physics for our games. Thank you for watching my hand physics tutorial. That was definitely a longer one. It was really complex. If you have any issues, please let me know in the comments. I'll try and help you out. I'm working on a Discord server so that we can not answer questions in the comment section anymore, and you can actually send me screenshots of what you're having trouble with. I'm also going to start working on my next tutorial, which is probably going to be weapons and inventory. I'm going to do them separately in videos, but I'm going to just release them both together. So we'll start with weapons and then we'll go into inventory. And that should wrap up most of what I want to do for the Half-Life Alyx series. And then I think like the last video I'll do for that series is probably like interacting with drawers, doors, and like, you know, other objects. Because now that we have the physics hands, we can kind of build on top of those. And then I might upload a few more videos just kind of going through like different ways that we can polish this physics system so that it works better and is a little bit more robust. I've been looking at this team called Beyond Sandbox, and they've been posting a bunch of videos where they have like really complex like finger physics going on. And I know they're using Unreal, so obviously that proves that it's possible. I don't know how they're coding it, but you know, it is something that we can pick apart and maybe recreate on our own. So I'm going to look into that as well. That's all though. Thank you for watching.